Today we are going to solve a deceptively simple-looking functional equation, f of x equals x squared minus x plus 1, and we have to find OF of 0. At first glance, this looks like a routine algebra problem, but hidden beneath this small expression is a beautiful chain of logic, symmetry, and insight. We start by putting the value of x equals to 0. This gives us f of 0 equals 1. Now we do not yet know what f of 0 is, so let us give it a name. Let us call it k. So now we have a clean and powerful statement. F of k equals 1. This is a key step, so let us hold on to it. Next, we substitute x equals k into the original equation. This gives us f of k equals k squared minus k plus 1. But we already know that f of k equals 1. So this immediately tells us that f of 1 equals k squared minus k plus 1. At this point, we are already starting to see a structure form, and we are just getting started. Now let us substitute x equals 1 into the main equation. This gives us f of 1 equals 1. Let us define f of 1 as m. Then this means f of m equals 1. Once again, we substitute x equals m into the original equation. This gives us f of m equals m squared minus m plus 1. But since f of m equals 1, this simplifies beautifully to f of 1 equals m squared minus m plus 1. But earlier, we defined f of 1 as m. So now we have a powerful equation, m equals m squared minus m plus 1. Rearranging, we get 0 equals m squared minus 2, m plus 1. And this is a perfect square. M minus 1 whole square equals 0, which gives us a single elegant result. M equals 1. So now we know that f of 1 equals 1. Let us return to our earlier equation. F of 1 equals k squared minus k plus 1. Substituting f of 1 equals 1 gives us 1 equals k squared minus k plus 1. The ones cancel, leaving us with 0 equals k squared minus k, or k into k minus 1. This gives us two possibilities, k equals 0 or k equals 1. But remember, k represents f of 0. Let us test k equals 0. If f of 0 equals 0, then f of 0 becomes f of 0, which equals 0. But earlier we found that f of 0 equals 1. This contradiction eliminates k equals 0. Now let us test k equals 1. If f of 0 equals 1, then f of 0 becomes f of 1, which we already proved equals 1. This satisfies the equation perfectly, and so we reach our final result. The value of f of 0 is 1. A small question, a simple function, yet a beautifully connected chain of logic.